electron. Are you positive? Oh, yeah. Really good, right? Really good. Because it's like electrons are negative,
every day.
positively charged. Oh my gosh. Here's what I need from you guys. You are either going to work on your bell work, which is the next page in your packet, or if you didn't have enough time at the end of the class yesterday, I want you to take that Tuesday lecture quiz and knock that out for me, okay? So you got two options. I'll put a few minutes on the clock. Go ahead and take care of this bell work or the Monday lecture quiz. Do that right away. Give you guys a few minutes. Let's get it cooking. Enough time. That's okay. All right. So what is our Z? Let's see here. Muhammad, talk to me. What is the Z?
The Z is the atomic mass.
Not the atomic mass.
Oh, hold on. Is that the protons or the atomic number?
Yep. Z is the atomic number, or you could also say the number of protons. So if I'm like, hey, what's the Z? Oh, I'm sorry. I mean, how many protons are, I'm sorry. What's the atomic number? I just asked you the same question 3 different times, okay, in 3 different ways. They all mean the same thing. Number of protons, atomic number, the Z, they're all referring to the same thing. The A is the atomic mass. The A is the atomic mass, okay? Now, if I'm looking at these, Z is just protons. A is protons and neutrons. So if I want to find the neutrons by themselves, what can I do? See?
Z minus A, or A minus Z.
A minus Z, that's right. If you think about it, okay, so A minus Z, so this is A, Z, so this is the number of protons plus neutrons. If Z is just the number of protons, if I subtract these two, that will cancel out and that'll tell me how many neutrons I have, okay? Which makes sense. Protons and neutrons are the big pieces in the nucleus of an atom. So if you take away the protons, you'll be left with just the neutrons in terms of mass. That's pretty good. Oh, let me see here. Hey, Gozer, can I change the number of protons of an atom? Is that a thing? Absolutely not. An atom is defined by how many protons it has. Well, okay, smarty pants, if you're so smart, if I can't change the protons to positive charges, how am I supposed to get a positive charge?
If you take away electrons,
Woo! My God, Gozer, yep. You have to remove electrons to have that happen. That's right. So the number of electrons can go up or down. If you need a positive charge, you're going to need to lose electrons, which seems a little counterintuitive. You're like, wait, positive means you lose stuff? But remember, electrons are negatively charged, so you're removing negative charge. Kind of think of it that way. Isabel, if you're looking for this is the bell work. It should be on the back of the page, I think, towards the front. Yep, there you go. Yep. Not bad, not bad. Let's knock out one of these. Oh, I don't know. We'll go with aluminum. Mr. Howard. So here's our full atomic symbol. So this tells us all the information. Okay, that's a full atomic symbol. How many protons does aluminum always have?
13.
You got it. All aluminums, no matter what, the moment you see that AL, you think 13 protons. Guaranteed. Okay. Now this aluminum's got a charge of +3, so how many electrons does it have to have? You are correct, actually. That is 10. There are 2 main ways I encourage people to figure this out. Way number 1, all conceptual. You think, okay, it's got a charge, so the protons and electrons aren't equal. It says plus. Okay, plus means there's more protons than electrons. Okay, it's like, well, how many more protons? 3. Plus 3 is 3 more protons. So if you have 13 protons, it means you should only have 10 electrons. The other way, which some people will vibe with this more, here's the equation. Remember, charge, this is something a lot of people wrote down yesterday, and I would encourage you to do so if you haven't already, is equal to the number of protons minus the number of electrons. So in this particular case, the charge we're told is +3. The number of protons is 13. So 13 minus what equals +3? That would be 10. So here's the deal. A lot of people are looking at this and they think to themselves, okay, I know the difference between the protons and electrons is 3, but I don't know whether to add 3 electrons or take away 3. So some people probably said 16 here for the electrons. I bet a lot of people did. So here's the thing. In this unit, it's not about being able to do the math. I know you guys can add 3 or subtract 3. If you can't, we got bigger problems. But I know you guys can do that, okay? That's not the problem. What can get a little tricky is knowing what math to do. Once you know the math to do, you can do it easy. But knowing what step to actually take, that's the kind of tricky part. And so you need to really make sure you're organizing your thinking. Okay, positive charge means more protons. Less electrons. Okay, all right. So the electrons are actually going to be less. So those are the kind of things you need to think about. Because these mistakes, they always make you feel like, oh, +3, that's so easy. But again, it's kind of tricky figuring out whether it's plus or minus. The math is easy, though. All right, not bad. Let's go ahead and move on from that. The key to that bell work is in the Tuesday folder. If you want to check the rest of them later, you're more than welcome to do so. Let's talk about the atoms, ions, and isotopes. The atoms, ions, and isotopes page here. So this is the next page. It's going to be our activity. All right, let's see here. Faith, can you tell me what charge a proton has? You got it. What about an electron, Faith? You got it. And neutrons? Look at you, smarty. Love it. Okay. An ion, we learned yesterday, is a charged particle. So it could be positive or negative. The positive versions are called cations. Remember, cats are positive. Oh my gosh, this is so good. And the negative ones are anions. We talked about, hey, I'm Mr. Pilcher, I'm anti-bullying. It means I'm negative bullying, I'm against bullying. Anion means a negative ion, okay? All right, so of these three, protons, electrons, and neutrons, when we're talking about charges and that kind of thing, which one of these do not affect that at all? Neutrons, right? When we're talking about charges, specifically talking about charges, we don't really care about the neutrons. 5 neutrons, 100 neutrons, it doesn't affect the charge at all. So neutrons really don't have any impact on ions. So on this page, once we find out the neutrons are one thing, we found out the neutrons are the other, because that's not going to be affected in any way. So here's what the point of this page is. We've talked about numbers. We've talked about, hey, this has got 3 electrons, 6 protons, whatever. It's one thing to know the numbers and to know the math. It's another thing to understand and be able to visually show me what you're talking about. That adds another layer of understanding, if you can visually demonstrate what you're talking about. So we're going to compare a lithium atom and a lithium ion. All right. So, Mohammed, when we're talking about a lithium atom, what does that tell us about the charge when we use the word atom?
It's 0.
Yep. The moment you see the word atom, by definition, all atoms are neutral, so it has a charge of 0. Okay? So we already know this charge is 0 before we even go anywhere else. All right. Now, let's see here. Mr. Blaze is the lithium. So how many protons does it have to have? Yep. All lithiums have 3. So what does that tell you about this lithium over here? Yeah, it's also got 3 protons. So if I'm going to start drawing my picture here, I'm going to plop some protons here in the center. The center is the nucleus, and that's where protons reside. So I'm going to throw a few plus signs in there. You should do that as well. Mr. Pilcher, exactly where should I put them? It doesn't matter. Just make sure on the inside circle, which represents the nucleus in these drawings. So I got my 3 protons there. I got 3 protons over here. Okay. Clark, am I getting in your way at all? You good? Okay. All right. So let's focus on the neutrons. Let's see here. Isabel, did I tell you the mass of this particular lithium? Did I give you any information regarding that? I did not. Okay, so because you don't have any outside info, you are forced to assume this is a typical lithium. So typically speaking, according to the periodic table, what's a normal lithium's mass about? Yeah, so closest whole number. Yeah, lithiums are usually about 7, and you get that from periodic table because she doesn't have any other information, so she's forced to just assume it's like a normal one. So we're just going to assume this is a lithium with a mass of 7. If that's the case, Isabel, 3 of that 7 came from protons, so how much of it came from neutrons? You got it. And since we already established that neutrons don't affect the charge at all, and the only thing that's changing from the left to the right is the charge. We know that this one's also got 4 neutrons. So I'm going to grab these guys. Boom. We got 1, 2, 3, 4 of these guys in there. Again, I don't really care what order you put them in, as long as they're inside that inner circle to show, hey, these are in the nucleus, Mr. Pilcher. I know these belong in the nucleus. All right. Okay, now the electrons. That's what we got to focus on here. This is on the left, we have a neutral atom with a charge of 0. So Oswald, if something has a charge of 0, what does that tell us about its protons and electrons? they're the same, right? They have to cancel out. So how many electrons? 3 electrons. And for now, we're just going to put our electrons just kind of flying around this little ring right here. That's not exactly how it is in real life, but for right now, this picture will be good enough. Good enough as we're getting started. Okay. And now, let's see here. Andrew. Over here, I got a charge of +1. So what is that? How does that affect my electrons? How many electrons am I looking at this point? 2. It'll just be 2. Again, if you're focusing on the charge equation, remember this. Charge equals protons minus electrons. He's thinking, okay, I'm told it's a +1. I know it's got 3 protons, so 3 minus what equals +1? 2. Now, I'm sure some of you guys were tempted to put a 4 there for electrons, but if you're focusing on that equation, you'll know it's only 2 electrons. So I grab a couple of these, plop, and plop. There's a little bit more difficult problem down here with fluorine. You can try that later if you would like. I'm going to go ahead and move on, so I want to let you guys work independently here shortly. Okay, so the first page focused on ions. The second page is going to focus on isotopes. Isotopes. So let's see here. Who can tell me the mass of a proton? Mohammed?
1.
What about the mass of an electron? 0, right? Electrons technically have a mass, but they're so small we call them 0. Mass of a neutron?
1.
Love it. And since isotopes are when you have 2 of the same element, 2 particles of the same element, but they have different masses because they're different number of neutrons. Before, when we talked about ions, we pointed out, hey, neutrons, they're not really going to affect the ion in any way in terms of its charge. Now, which of these 3 particles do we no longer care that much about when we're focusing on mass? The electrons, right? Because electrons basically don't have mass, so it's like, oh, there's 4 electrons, or I mean 5 electrons, like, oh, whatever. In terms of mass, it doesn't really change anything. So we're going to focus on the protons and the neutrons here because they are the ones with mass. All right, so let's talk about carbon here. Isabel, carbon isotope. How many protons does carbon always have? Yep, you got it. Boom. It's always got 6. And so we know this is also carbon, so this definitely has 6 as well. So that's kind of nice. We know both those answers right away. I could drag 6 positive signs into this middle circle down here, but I'm not going to worry about that. But you need to be able to do that. All right. So I'll stick with you on this one, Isabel. We're told that this whole isotope's mass is 12. 6 of that came from protons, so how many neutrons does it have to have? You got it. Okay. Isabel, are we told anything about the charge here? So we have to assume that the charge is 0, right? So since we're not given information, we have to assume it's 0, the charge anyways. So we have 6 protons. We have how many electrons? You got it. Okay. Of course, that atomic mass is 12. Now over here, this has an atomic mass of 14. So Isabel, will that affect the number of electrons at all? No, because electrons, they don't really have a mass, and they only affect charge, and the charge hasn't changed, so we're good there. So what does change? What's the only way you can change the mass of an atom? The neutrons. How many neutrons do we have now? She's correctly saying 8. And where'd that 8 come from? How'd you know it was 8? Right, or what you did the first time was 14 minus 6 equals 8. Yep, you did it so fast it's hard to realize what you did. Yeah, you just immediately saw that. So the total mass is 14. 6 of it still comes from protons, but now 8 of it must come from neutrons. Yep, 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 yep. And so the difference in isotopes is here. Emphasis here with the neutrons. Whereas, I'll come back to this in a quick second, the difference in ions is here with the electrons. Electrons affect charge, neutrons affect mass. Okay? So those are the sort of things you need to be looking for when you're comparing ions or isotopes. Now, let's get to the activity for today. Okay? You're going to do a lot of counting. Now, this is the worksheet you're going to be filling out. You're going to fill out this whole thing. All right? But at least you get to go at your own pace and you can kind of choose how you do things instead of having to listen to me talk the whole time, which no one wants to do that. except where I'm telling sweet dad jokes. All right. Oh my gosh. All right. Anyways, so I normally hand this out, and around the room, this next picture isn't great quality, but around the room there's these little petri dishes. They have different beads in them. So there's like green beads here, and there's like red and blue beads. Oh, you can't even see that. Goodness. There's like red and blue beads here. So there's a nucleus right there. It's sort of like the inner circle. And on the outer circle, you have like your little green beads, like here and here and here, that kind of thing. Don't worry, if you can't quite see this picture very well, you will get a much higher quality picture here in a moment. But here's what this is a picture of, this guy right here. So for virtual folks, can you see this little petri dish? So on the inside of this petri dish, okay, we have a little tiny petri dish. That is our nucleus. That's where protons and neutrons are. On the outside of that are little green beads. Those are our electrons, okay? So there are 14 stations. These are usually around the room. You usually have to walk around the room. You have to count your protons, neutrons, and electrons. And then you're going to answer questions about those. So if I was doing station 1, I'm going to walk you through station 1. So here are numbers that you can actually use. Station 1, it's got 7 protons, okay? Nice. It's got 1, 2, 3, 4, 5, 6, 7 neutrons. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. And I'm just looking at the petri dish. I will give you guys pictures of these momentarily. So you'll have your own pictures where you can count your own. But if we're doing this first one together. Okay. Now with just these 3 columns right here, the protons, neutrons, electrons, you should be able to answer all the other questions about this particular particle. Okay? So I'm going to do that real quick with you. All right, mass number. Mr. Howard, mass number concerns which of these particles?
The neutrons and the protons.
That's right, the neutrons and the protons. So this guy plus this guy will give you your mass number. So my mass would be what, Mr. Howard?
14.
You got it. Let's see here. CC, which one of these subatomic particles tells us what element this is? Okay, so I have 7 protons. So this must be what element?
Nitrogen.
You got it. What is the symbol of nitrogen? You got it. Okay, so see the difference between the element name and just a simple symbol? Now, the full atomic symbol is when you have that symbol in the center and you include all the other pertinent information. So that is where you have your A, your Z, and your charge. So let's fill those in. All right. So my mass, well, I already got that. That's 14 for this particular one. My number of protons is 7. And what should the charge on this one be? Let's go with Oshwak. Talk to me about the charge. What is the charge on this guy? -3. She was ready for it. So remember, protons minus electrons, in this case, 7 minus 10. Got her -3. And so that is what you need to do. So here's what I want you guys to do first. Okay? When you get to this worksheet online here momentarily, I want you to get these 3 columns completed first. So like fill all of this out first and then answer the questions about them. So I want you to run through all the pictures, count everything. Okay? Today, here's what you got to get done. You definitely got to get all your counting done. And then the more of this chart you can finish today, the better. You don't have to worry about doing this at home, but make sure if you don't finish the counting today, you should definitely do that at home. Okay? The other thing you need to do today, besides the counting, is you definitely need to do your Tuesday quiz. So you should knock that out. They're both in the Tuesday folder. So in the Tuesday folder, you'll find your quiz, but you'll also find something labeled Atoms, Ions, and Isotope Slides. It has very high-quality pictures of all these petri dishes, so you can do the counting on your own. Okay? So it's in your Tuesday folder on Schoology. You guys can go ahead and bust that out. And a couple quick announcements. Wednesday we'll do lots of practice, and you'll have plenty of time to finish the rest of this. So as long as you got your counting done before you come to class tomorrow, you'll be in good shape. Okay? Thursday, in-person people will be doing the flame test lab, which it is exactly what it sounds like, a flame test. So you're going to be lighting stuff on fire the whole day. It's going to be great. And then Friday's your weekly quiz. And I'll say this again later this week, but on Monday and Tuesday next week, there won't be live class. There'll just be recordings in the Monday and Tuesday folder to pair up with your quizzes. So you don't have to see me at any specific time next week. Does that make sense? All right. Virtual folks, do you have any questions for me before I let you go? Any questions, virtual people? Hold on one second. I couldn't quite understand you, Adam, but it's not your fault. It's my speaker's fault. Let me see here. Hey, Adam. Say that one more time for me.
So, photons and neutrons in the pictures, are they color coded? Like,
Oh, yes. Yep. The pictures have a key. It tells you what each color means. It'll be really straightforward when you open one.
okay.
Yep. Good question. Any other questions, virtual folks? All right. Knock out all of those counting, all that counting, and knock out your quiz, and you're good to go. See you, virtual people.